Hi everyone, in this video I'm going to explain how preemptive priority scheduling algorithm works. In this question we've got four processes P1 till P4 with 4 arrival times, 4 burst times and 4 priorities. Remember that the least number, which is 1, shows the highest priority and the greatest number, which is 4, shows the lowest priority. So the order and the rank of priorities are 1, 2, 3 and 4. Also, this is preemptive priority scheduling algorithm. It means that at any given time, when a new process arrives, we can stop the current process running and switch it with the new process with the higher priority. To solve this question, what I do first, I draw the timeline for the arrival of different processes. So P1 arrives at millisecond 0, P2 arrives at millisecond 1, P3 and P4 as you see here. And what is important to draw the right and correct Gantt chart to answer the question, which is the turnaround time and waiting time for two processes. Because this preemptive algorithm, I do recommend to write and draw the arrival of different processes on the Gantt chart because it helps you to know at what point you can switch between different processes. So we are at millisecond 0 and the only process that we have is P1. There is no other processes, so P1 gets CPU time till we get to millisecond 1. At millisecond 1, we've got two processes, P1 and P2. Now we can choose whether to continue with P1 or stop P1 and give the CPU to P2. For this case, we look at their priorities. As you see here, P2 has the highest priority. In that case, definitely we need to switch. In that case, 1 millisecond of P1 goes, 5 milliseconds remains, and P2 gets CPU time because it's got the highest priority, and it goes for the whole 3 milliseconds because there is no other process that can beat this one. So it goes from 1 till millisecond 4 because it needs 3 milliseconds. Now we are in millisecond 4. All the processes are there and we can choose between the next process based on the priority. So as you see here, the next one is process 3. So process 3 gets CPU time and it goes for 1 millisecond. 1 millisecond. There you go. Nothing remains and it leaves, process 3 leaves the CPU. The next one between 3 and 4, number 3 has a higher priority, which is P4, and it goes for 2 milliseconds and leaves the CPU at millisecond 7. And the last one, which is priority process 1 with the least priority, and it leaves at millisecond 12. Now the next step is to complete the table. The next column I need to add to this table is exit time. It's very important to know at what millisecond which process leaves the CPU. For this purpose, I always start from right to left because it helps me to identify the processes and their leaving time. So P1 leaves at millisecond 12, P4 leaves at millisecond 7, P3 leaves at millisecond 5, and P2 leaves at millisecond 4. The next column is turnaround time. Turnaround time by definition is exit time minus arrival time. Turnaround time, which is exit time minus arrival time. Easy. The first one, 12 minus 0 is 12. Next one, 4 minus 1 is 3. 5 minus 2 is 3. 7 minus 3 is 4. And the last one is waiting time. Waiting time. Waiting time by definition is turnaround time minus burst time. It means that I need to subtract these two columns, but don't forget I need to stick to the original values of the burst time. So 12 minus 6 is 6, 3 minus 3 is 0, 3 minus 1 is 2, and 4 minus 2 is 2. So what I need to do, I need to identify the turnaround time for P2, which is this one, 3, and waiting time for P4, which is 2 milliseconds. I hope I explain everything about the preemptive priority scheduling algorithm and helped you to understand this step by step. Thank you very much.